Now, this is the second part, and here I will talk about thermal expansion. What does that mean? This means how really materials they're gonna interact with heat, and how they are going to maybe change length or area or volume based on absorbing heat or rejecting heat. Um, In this example here, I'm going to have a rod that has a length L at an initial temperature Ti, and then I was able to warm it up to T final, and then the length has changed to L plus delta L. And in order for me to calculate what is the change in that length, we are going to have it as alpha times L times delta T. Now, what are these here? Okay, delta L is the change in length in meters. Alpha, we call it coefficient of linear expansion, and it has the units of per degree Celsius. This coefficient is different for different materials. Delta T, it is the change in temperature, and always is going to be T final minus Ti. Now, you don't have here, whenever it is delta T, which is a temperature difference, you don't have to convert into Kelvin. The reason is that when you gonna convert T final plus 273.15 minus Ti, you're gonna subtract also negative 273.15, and these they're gonna cancel. Then again, it's gonna go to T final minus T initial. Now, one more thing, which is if I have something that has an area, and then therefore, like you have two dimension, each is gonna expand by the rate of alpha. Therefore, the change in the area is going to be 2 alpha times A times delta T. And the change in the volume is going to be 3 alpha times the volume times delta T. Now, this is for solids. Now, if I have gases or liquids, we can say delta V is going to be, there is a coefficient of volume expansion, we call it beta, times V times delta T. And V here, it is the initial volume, and delta V is the change in the volume. Just to show you how we're going to use these, how large an expansion gap should be left between steel railroad rails if they may reach a maximum temperature of 35 degrees Celsius greater than when they laid. The original length is 10 meters. And this, a problem is bringing to us so many applications that we can look around and see how actually they are, kind of having, um, uh, you know, taken into consideration what is called the thermal stresses, or really the thermal expansions. This is going to be the case when they want to have a new railroad rails, or when they are going to have, let's say, communication cables or electrical cables or anything. They need to consider these stresses. Now, in this question here, since we are talking about steel, then alpha for steel should be given, and that alpha is 1.210 to the negative 5 per degree Celsius, and delta L is alpha times L times delta T, and then delta L, it is alpha, which is 1.210 to the negative 5 per degree Celsius times 10, which is the original length, times the change in the temperature, which is 35 degrees Celsius, and that is going to be the change in the length of that railroad. Here also talking about expansion in liquids, and also volume expansion in solids. Here, a physicist makes a cup of instant coffee and notices that as the coffee cools, its level drops 3 millimeters in the glass cup, show that this decrease cannot be due to thermal contraction by calculating the decrease in level if the 350 cubic centimeters of coffee in a 7 centimeter diameter cup and decreases in temperature from 95 to 45. Most of the drop in the level actually it is to the escaping bubbles of air, and that's like explaining to you why we cannot say it is just because of the thermal contraction. Now we know that the volume for the coffee is 350 cubic centimeters. The radius of the cup is 350. Remember, it was given the diameter, then I need to have the radius. The TI is 95 and T final is 45. The volume of a cup, it is very similar to the volume of a cylinder, which is pi r squared times h. These formulas and equations, you need to know them in the exam. I will not provide them. You need to know what's the volume of a cylinder, what is the volume of a sphere. Delta V equals the change in the volume is pi r squared delta H, and therefore that change in the volume is going to be the difference between the two beta W minus beta glass times V delta T, and that equals pi r squared delta H, and then delta H was actually calculated